if u is equal to xy plus yz plus zx, where x is equal to t into cos t, y is equal to t into sin t, z is equal to t, and t is equal to pi by 4. Here also we have to find the total derivative for the function u is equal to xy plus yz plus zx, and also we have to verify this function using direct substitution. Here first construct the picture. Here the function u depends on three variable x, y, z, and the variable x, y, z depends on a single variable t. In that case, the total derivative of a composite function is given by the formula du by dt, which is equal to del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. To find the total derivative, we have to first find del u by del x, del u by del y, del u by del z value. Also, we have to find dx by dt, dy by dt, and dz by dt value. For that, consider the given function u is equal to xy plus yz plus zx. Call this as equation number 1. We have to differentiate partially with respect to x, y, z. We get del u by del x value as, here del u by del x, we have to differentiate partially with respect to x, means we have to treat y and z as constant over here. Here in the first, x into y is, here y is constant, take as it is, into differentiation of x is 1, plus here y and z both are constant, here differentiation of constant is 0, plus here z is constant, take as it is, into differentiation of x is 1. Hence we get del u by del x value as y plus z. Similarly, we get del u by del y value as, here x is constant, take as it is, into differentiation of y is 1, plus here z is constant, take as it is, into differentiation of y is 1. Here this value becomes 0, hence we get del u by del y value as x plus z. Similarly, we get del u by del z value as, here this is constant, differentiation of constant is 0, plus here we have to treat y and x as constant, so take y as constant as it is, into differentiation of z is 1, plus x is constant, take as it is, into differentiation of z is 1. Hence we get del u by del z value as y plus x. After finding del u by del x, del u by del y, and del u by del z, again we have to find dx by dt, dy by dt, and dz by dt. Further, take the given values, x is equal to t cos t, y is equal to t sin t, and z is equal to t. Here we have to differentiate these values with respect to t. We get dx by dt value as, here t and cos t both are function, we have to apply product rule over here. Here cos t as first function into derivative of t is 1, plus second function, that is t, into derivative of cos t is minus sin t. Hence we get minus t sin t. This is our dx by dt value. Similarly, we have to find dy by dt as, here also t and sin t both are functions, so we have to apply product rule over here. Here take sin t as first function and t as second function. We get first function into derivative of t is 1, plus second function, that is t, into derivative of sin t is cos t. Similarly, we have to obtain dz by dt. Here z is t, hence we get dz by dt value as 1. After finding all these values, we have to substitute in the formula, that is du by dt, which is equal to del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. Substitute values here, we get here del u by del x is y plus z into dx by dt value is cos t minus t into sin t, plus del u by del y is x plus z into dy by dt value is sin t plus t into cos t, plus del u by del z value is y plus x into dz by dt value is 1. Here in the next step, we have to substitute x, y, z values over here. We get here y is t into sin t plus z is t into cos t minus t into sin t, plus x is t cos t plus z is t into sin t plus t into cos t, plus y is t into sin t plus x is t into cos t into values 1. Multiply inside the bracket and simplify, we get the value as t into sin t into cos t minus t into sin t into sin t, we get as t square into sin square t plus t into cos t plus into minus t square into sin t, plus here t into cos t into sin t is t sin t cos t, plus here t cos t is t square cos square t, plus t into sin t, plus t into cos t is t square cos t, plus here t sin t plus t into cos t as it is. Here t into sin t we have, here also t into sin t we get the value as 2t into sin t into cos t. Here we have minus t square into sin square t. Here we have plus t square into cos square t. Hence we can take t square common, we get as t square into cos square t minus sin square t, plus here we have minus t square into sin t plus t square into cos t. If we take plus t square common, we get as cos t minus sin t, plus here t into cos t plus t into cos t we get as 2t into cos t. Here also plus t into sin t and plus t into sin t we get as 2t into sin t. If we take plus 2t common, we get as plus 2t into cos t plus sin t. We have to simplify carefully. Here in the problem, they have mentioned to find the total derivative of a function at the value t is equal to pi by 4. So, in the next step, substitute t value as pi by 4 over here. We get du by dt value as 2 into, in the place of t we have to substitute as pi by 4, 2 into pi by 4 into sin pi by 4 into cos pi by 4 plus, here t square is pi by 4 whole square into cos square t is cos square pi by 4 minus sin square pi by 4 plus pi by 4 whole square into cos pi by 4 minus sin pi by 4 plus 2 into pi by 4 into cos pi by 4 plus sin pi by 4. We all know that sin pi by 4 and cos pi by 4 value is 1 by root 2. That is sin 45 degree and cos 45 degree value is 1 by root 2. Substitute that value here. We get 2 into pi by 4 into, here sin pi by 4 is 1 by root 2 into cos pi by 4 is 1 by root 2 plus pi by 4 whole square as it is into cos square pi by 4. That means 1 by root 2 whole square. Square and root get cancelled, hence we get 1 by 2 minus 1 by 2 plus pi by 4 whole square into cos pi by 4 is 1 by root 2 minus 1 by root 2 plus 2 pi by 4 into 1 by root 2 plus 1 by root 2. Here also 1 by root 2 minus 1 by root 2. Here also 1 by 2 minus 1 by 2 gets cancelled. The remaining value is du by dt, which is equal to here 2 into pi by 4 into 1 by root 2 into 1 by root 2. Simplifying we get 2 ones are 2 twos are. Here 2 into root 2 we can write it as root 2 whole square. Hence we get cancelled root and 2. Hence we get the value as pi by 4. Here 2 into pi by 4 into 1 by root 2 plus 1 by root 2 we can write it as 2 by root 2. Here 2 ones are 2 twos are. Here 1 2. Here 2 gets cancelled. Hence the remaining is pi by root 2. Hence we get the du by dt value as pi by 4 plus pi by root 2. This is a total derivative for the function u. Also we have to verify the value using direct substitution. Here u value is xy plus yz plus zx and x value is x is equal to t cos t, y is t sin t, z is t. Substitute xyz value over here, we get u value as x is t into cos t into y is t sin t plus y is t sin t into z is t plus z is t into x value is t cos t. That is t cos t into t sin t, that becomes t square into cos t into sin t plus t sin t into t is t square sin t plus t into t cos t is t square cos t. Here we have t square into cos t into sin t. To make the simplification easy, we can multiply and divide for this equation by 2. We get the value as u is equal to 1 by 2 into t square into 2 into cos t into sin t plus t square sin t plus t square cos t as it is. Here if we cancel the two terms, the remaining is t square into cos t into sin t itself. Hence in the next step, we know that from the double angle formula, sin 2x we can write it as 2 into sin x into cos x. Substitute that value over here, we get u is equal to 1 by 2 into t square into, here 2 cos t into sin t is sin 2t plus t square sin t plus t square cos t as it is. This is our u value. We have to obtain du by dt. For the differentiate u with respect to t, we get du by dt value as, here 1 by 2 is constant, take as it is, into, here t square and sin 2t both are function. So we have to apply product rule over here. Take t square as first function and sin 2t as second function. That is, first function into differentiation of sin 2t is cos 2t into, again we have to differentiate this 2t term, that is 2 plus second function, that is sin 2t into differentiation of t square is 2t plus, here also t square and sin t both are function. Hence you have to apply product rule for this also. First function into differentiation of sin t is cos t plus second function, that is sin t into differentiation of t square is 2t plus t square into differentiation of cos t is minus sin t plus cos t into differentiation of t square is 2t. In the next step, we have to multiply 1 by 2 inside the bracket and simplify. We get as, here 1 by 2 if we multiply inside the bracket, here 2 gets cancelled, here also 2 gets cancelled. The remaining is t square into cos 2t plus t into sin 2t plus, here we have t square into cos t and here we have minus t square into sin t. If we take plus t square common, we get plus t square into cos t minus sin t plus, here also 2t into sin t plus 2t into cos t. If we take 2t as common, we get plus 2t into cos t plus sin t. In the next step, we have to substitute at the value t is equal to pi by 4. In the place of t, we have to substitute as pi by 4. We get du by dt value as, here we have t square, hence we get pi by 4 whole square into cos 2 into, in the place of t, we have to substitute as pi by 4. Here 2 ones are 2 twos are, hence we get cos pi by 2. Plus here also t is pi by 4 into sin 2t is sin 2 into pi by 4. Here 2 ones are 2 twos are, hence we get sin pi by 2. Plus t square is pi by 4 whole square into cos pi by 4 minus sin pi by 4 plus 2 into pi by 4 into cos pi by 4 plus sin pi by 4. We know that sin pi by 4 and cos pi by 4 value is 1 by root 2 and cos pi by 2. Here sin pi by 2 value is sin 90 degree, sin 90 degree value is 0 and cos 90 degree value is 1. Pi by 4 whole square into, here cos pi by 2 is 1 plus pi by 4 into sin pi by 2 value is 0 plus pi by 4 whole square into, here cos pi by 4 minus sin pi by 4 is 1 by root 2 minus 1 by root 2, hence we get 0 plus pi by 2. Here 2 gets cancelled, hence we get pi by 2 into cos pi by 4 plus sin pi by 4. We know that cos pi by 4 and sin pi by 4 value is 1 by root 2, hence we get 1 by root 2 plus 1 by root 2. Here this value is 0, this value is 0, and after simplifying all these values, we get the value of du by dt value as pi by 4 plus pi by root 2. This is same as before, hence we can conclude that the total derivative value for the function u is du by dt, which is equal to pi by 4 plus pi by root 2. This completes the problem.